Okay, example 6. Every example, can you have attention? We try not to give you too many examples, but every example we give you must have something different, something different. Example 6 is one that students don't really like because it involves you to come up with something that you are to show. You are to prove. That means, have attention. Okay? Example 5, example 4, before all those examples, the question explicitly tell you what to prove. But if you notice the question, example 6, they ask you to suggest a general formula and then prove your conjecture by induction. That means if you cannot suggest, there's nothing to show. There's nothing to prove. Sounds scary, right? But don't worry. If you pass PSLE, then surely you can do it. Because it's all spotting pattern. Right? You all like those kind of pattern, PSLE type, Okay, can. Let's try. Never mind, let's try. Okay, come back, example 6. Have attention. Can? Ready? First thing they want you to do, calculate the values of this. Now, what are you given? You are given this recurrence relation here. Again, recurrence relation, this is given. Nothing to show. This defines U1, defines U2, defines U3. So, which is not difficult, right? U1 plus 1 over 3. What is U1? U1 is 5. Substitute in. Can? What is U2? U2, you read here. U2 is 2 times U1 plus 1. Correct? Correct? 1 times U1 plus 1 is 11. So this is U2. How do we get U2? U2 is 2U1 plus 1. Can? Need me to elaborate? Can? So this is U2. What is U3? U3 is 2U2 plus 1. What is U2? U2 is 11. That's why you get 23. Can? How do you get 47? 47 is 2U3 plus 1. What is U3? U3 is 23. Can? So, we have found, you got 2, 4, 8, 16. Come on. Cannot tell the general formula, man? Can. So, the guess is UN plus 1 over 3 is 2 to the power n. Let's check whether this guess is correct. This is the most important thing. Let's check. I sub n equals to 1, I get U1 plus 1 over 3 equals to 2 to the power 1. Correct. This is verified. Correct? Yes? Sub n equals to 2, U2 plus 1 over 3 is 2 to the power of 2. So 4. Correct. Can? Now, we want to suggest a general formula for UN. So we make UN the subject of the formula. I multiply both sides by 3 and then minus 1 on both sides. I will get UN equals to 3, 2, and minus 1. Can I make UN the subject? This is the guess I'm making, and I want to prove it. Okay. Some of us may ask, why do I need to prove? I have shown correct one. 2, 4, 6, 8. Follow pattern, of course correct. Remember my example of what example did I give? VJC boys are Handsome. Oh, okay, yeah. Oh, yeah. Oh, so you cannot say that this formula is always true. I have only shown 4 boys are handsome. I have not shown all the boys are handsome. I must prove all boys. Follow what I'm saying? So, then we follow the steps, 5 steps. Step number 1, let Pn be the statement. What's the statement? What is it that we want to show? We want to show this explicit formula un equals to 3 2n minus 1. Sorry. Minus 1. Is that all? For what? For all n, for all positive integers n. Okay, step number 1, why positive integers? Because I start off with u1. Look here, u1 is 5, so it is only true for all positive integers. Alright, can I? Second step, consider first case P1, very explicit. U1 is, this is given. U1 is 5 is given. Substitute 1 into the formula. You will write this step, must write this, equals to 5. So P1 is true. Step number 3, assume PK is true for some positive integer k. What does it mean? That means uk equals to 3 2k minus 1. Correct? I cannot emphasize this enough. We are only assuming for some k. Yes, I just changed the n with 2k. So, okay, all printed. So better pay attention, okay? Now, left-hand side of k plus 1, we want to aim towards the answer, which is the right-hand side here. This left-hand side is right-hand side. From here to here, again, use the recurrence relation. Oh, okay? This is using recurrence relation. From here to here, it is using step number 3, which is here. Here. Because UK is this. Correct? Then the rest is, you know lah. 2, we are better highlight in case some of you are a bit confused. 2 times 2 to the power of k, you get 2 to the power of k plus 1. Correct? You add the index up. And then you have 3, okay, 3 is 3, 2 times minus 1, you get minus 2. Okay, and on and on. Okay, done. Yeah, done. Can quite easy, Can? Better write one more line here. Step number 4. This is step number 4, sorry. Therefore, PK true imply PK plus 1 true. And there you have the conclusion. Oh, so fast, finishing already. So good. Okay, this is the most fun part. I like this most. No, not yet. 7 yet. Still 7. 70.4 is my favorite. But never mind. Let's do 70. Example 7 first. Can? Example 7. Okay. Very quickly, find the values of S1, S2, S3, S4. S means what? S means sum to S. N actually means sum to n terms. Never mind. Let's do it, and it should be quite easy. What is U1? U1, you just write 2 times 1 minus 1, which is actually equals to 1. Then we do this one first, U1, 2, 3, 4 first. Then it's easier to find S1, 2, 3, 4. Follow what I'm saying? Okay, you want to do faster, that means doesn't matter, go ahead, okay? Can? 2 times 2 minus 1 equals to 3. U3, you just sub 3. Ayo. So easy, ah. Too easy, ah. U4 is 2 times 4 minus 1 equals to 7. Okay? Then you find S1, 2, 3, 4. Okay, you find. Ayah. Come. You all can do it. Right? S1 means U1 lah. S2 means U1 plus U2 lah. Correct? Sum to n terms, right? Can, you can do it. Yes. I know it. Okay, S1 obviously is U1. Is U1 plus U2 equals to 4. U1 plus U2 plus U3 equals to 9. U1 plus U2 plus U3 plus U4 equals to 16. Now obviously we observe 1, 4, 9, 16. Is there a pattern? Yes. 1 square, 2 square, 3 square, 4 square. So therefore, make a conjecture here. Actually shouldn't have put this answer here for you all to come out on your own. The conjecture is Sn, S1 is 1 square, S2 is 2 square, S3 is 3 square, S4 is 4 square. We would like to think that S5 is 5 square, S6 is 6 square. A bit too much talk. Thank you. Okay. Okay, put your friends up if your friends are sleeping, okay? Okay, do the right thing. Because seriously, if your friend wants to sleep here, then might as well go library and sleep. I always say, right? Okay. Okay, let's start. Prove your conjecture by induction. Step 1. Can you have attention? Ready? Okay, that's the problem. When I print too many things for you, then you all start to talk. This is the conjecture. The conjecture is Sn is this. And what is actually Sn? Sn is this one, right? Correct? So you write it in summation. This is what you want to show. Okay? Consider P1, which is the first case. Again, I cannot stress this enough. Must write this. Okay? Must write. Okay, must write. Not better. It's not an option. You must be very explicit. Right hand side, just put 1 square, done. P1 is true. Step number 3, assume Pk is true for some positive integer k, and you write what it means. Step number 4, we want to show Pk plus 1 is true. This is left hand side, this is right hand side. Again, we always start with left hand side. Am I going too fast? No, okay. As with all summation kind of induction problem, you look here, this is k plus 1, we would break it up to 1 to k plus the k plus 1 term. This, too much talking. k plus 1 term. Alright, if you find yourself sleeping, then write something lah. That's what I do. Write something. Now, from here to here, it is then making use of step number 3. Correct? Because this is this k squared. You can replace this with k squared. Then you factorize. You realize that you want to aim towards k plus 1 square. Ak plus 1 square. Done. Can? Now, then we say, therefore, pk true imply pk plus 1 true. And then your conclusion. All right. I say